Assalamu alaikum, guys. Welcome to class. This is the sixth grade class. We're going to go over equivalents and expressions today. This is, I believe, the third day that we're learning online. This is for the assignment that is going to be due on 3/19, okay? So 3/19 at 7 p.m., this is the assignment that's going to be due. So let's go ahead and hop right into it. Equivalent expressions are what? Things that we've been working on: the community property, distributed property, associated property, all these properties, and we want to see if things are equal to each other. But we're also going to be dealing with algebraic expressions, and we might have to even simplify some of the expressions that we have, and we'll go over all those things in a bit. So let's jump right into it. So I'm going to pull it up right now. So the problems that I circled are the problems you guys have to do. So you guys have to do number 16, 21, 23, 24, and 25. Hopefully, we'll go over all these ones right now. A lot of them are really easy and really fast, so hopefully we can get through it really quickly. So it says 3 students are sitting in the first row. In the second row, 3 students are sitting behind each of those students, and so on. How many students are in the 5th row? So for example, you have 3 people, right? And then each of those 3, they have 3 sitting behind them. Is that right? I'm not sure. So you have 3 students sitting in the row. In the second row, 3 students sit behind each student, right? And then the next one is going to split into 3, 3, 3, 3, 3, 3, I believe. So how many people are they going to be in the, oh, sorry. That's why I'm doing it wrong. Let me write it again, guys. So you have 1 student, 1 student, and 1 student. Each of these ones have 3 behind them. So this one has 3 students behind them. This one has 3 students behind them. And then this one has 3 students behind them. And then each of those 3 have another 3 that's behind them, right? So another 3 would be like this. So this would be 3, 3, 3, 3, 3, 3, and 3, 3, 3. Okay? So if you guys think about it, this is like 3 to the 1 power because there's 3 people in the first row. This one would be what? 3 to the 2nd power because you have 3 times 3, 3, and 3. So that's a total of 9, right? 3 squared is equal to what? 9, right? And then this one would be what? 3 to the 3rd. Why is it 3 to the 3rd? Because remember, these are the numbers I'm adding up, right? So I have 3 people. So the first row has 3 people. And then the second row has three behind each one. So that's that. And so all these ones are adding together as well. And if you look at them, there's 9 of them, right? So 3 times 9 is 27. 27. So to find the answer, it's just 3 to the 1, 3 to the 2, 3 to the 3. We want to find out in the 5th row. So we just have to find out 3 to the 5. Okay? So let's go ahead and find out what 3 to the 5 is. So 3 to the 5 is what? 3 times 3 times 3 times 3 times 3, right? So we're going to delete that part, 3 to the 5. So 3 times 3 times 3 times 3 times 3. So this equals 9. This also equals 9. And this one equals 3. So I'm going to multiply each one of these ones now. This is going to be equal to 81 times 3, which is equal to 243. So in the 5th row, there's going to be a total of 243 right there. Okay? Now for number 15, it says use exponents to write in an equivalent expression. So remember, exponents has these guys written in one small term. The number that's repeating, that's multiplying, that's the base. So what is being multiplied? 2.9. So that's the base. Now, how many times is it multiplying? So how many times is it multiplying by itself? Right? So it's, if we count it, it's 1, 2, 3, 4. So this is just 2 to the 4, or 2.9 to the 4. Right? You guys can also do this one. Like if you have two, let's say it was 3.8 times 3.8 times 3.8 times 3.8 times 3.8. Sumaya Yang, what would the base be? The one that is repeating over and over is 3.8. So the base would be 3.8. Good job, Sumaya. And then let's go to my favorite student. Dun dun dun. I don't have a favorite student, so too bad. But let's go ask Tamima. What would it be? How many times did I write it? 1, 2, 3, 4, 5. So this would be 3 to the 8 to the 5. 3.8 to the 5. Okay, so just real quick, just make sure you guys know how to rewrite those numbers. Okay, so this one is going to get, again, 2.9 to the 4. Find the prime factorization of 456. Wow, this is a tough one that you guys are going to have to do, but I'll get you started. 456. The best thing to do is just divide it by 2, and I'll give you guys a hint. It would be 28. It'd be 228. And then you're going to have to keep splitting it. And every time you run into a prime number, you're going to circle it, okay? So that's how you're going to go ahead and do number 16. We're going to continue on. So it says Allison wants to cut a rectangle with an area of 54. What are the possible whole number lengths and widths of the triangle? So for length, I'm going to put as W, and width, I'm going to put as this. So I can definitely do 1 and 54. I can also do 2 and split this in half as 28. Can I use 3? I can't use 3, but I can use 4. I can use 4 and 14. Can I use 5? No. Can I use 6? I think I can use 6, right? Did I split this wrong? I think I split this wrong. 54 divided by 2 is actually 27. So therefore, I can't even use 4 actually, but I can use 3. If I use 3, I do 54 divided by 3, which would give me the width of 18. Yes, I believe it's 18. Okay. Yeah, so it's going to be 18. And then we go to 4. 4 doesn't work. 5 doesn't work. 6 works. 6 and 9 work. 7 doesn't work. 8 doesn't work. 9 works. So 9, and then it just follows the pattern. So then this would be 6. I'm going to erase this for you guys real quick. So 6, because why I'm writing it again over is because that these are the possible lengths, right? So I can make my length like this and then my width like that. But I could also make my length like this and my width like that. If this is 5 and this is 5 and this is 1 and this is 1, it's the same thing, but just the lengths and the widths are switched around. Okay, so 9 and then 6 times 9. I already have that one. Which ones don't I have yet? 18. I have 18. And then I have 27. Then I have 27 and then 54. So then just write these ones down. 3 right here. 27 is 2, and then 1 is like that. So those are all the possible dimensions that we have for a square or a rectangle with an area of 54. Okay, because it's just length times width to find the area of a rectangle. Okay. So now, which operations could you perform first when you simplify the expression? So we don't even have to solve it. It just wants us to tell us which one are we going to do first. Well, we know we're supposed to do PEMDAS, which says parentheses and inside. But even in the inside of the parentheses, I have 2 things that's going on. I have multiplication that's going on, and I have addition that's going on. Which one do we do first? Remember, they're not twins. Multiplication is always older, so we always have to do multiplication first. So we have to do this first. And you get 75. So which operation should you perform first? Multiply 5 and 15, or 15 and 5. Okay, but now when we do number 19, we're gonna have to actually solve it. Okay, so it says simplify the expression using the order of operations. So the first thing, I'm gonna write it down. So I have 2 plus 3 times 7 minus 1 plus 3 squared. So I have to do PEMDAS first, so parentheses first. This says 7 minus 1. I know my handwriting is bad. I'm going to write everything before it and everything after it. Okay? Shafari, tell me what I'm supposed to do next. Yes, I'm supposed to do exponents first. So I get 9, and then this is multiplying. plus, and then 2. And now I have plus, multiply, and plus. So I have to do multiplication first. I'm going to do 18. Write everything before it and everything after it, right? So now this is what I have. Now it's all addition, so I just go ahead and add it up. This becomes 20 plus 9, which equals 29. This equals 29. Okay, so now 20, I was going to assign it for you guys, but then I noticed that some people might get confused, right? So it says write a number, algebraic expression to represent b less than 50. So some people will just go ahead and say, oh, it's b minus 50. That's not correct, and I'll explain why. So let me rewrite this. Instead of saying b, I'm going to say 10 less than 50. What is actually 10 less than 50? Nobody's going to say 60, right? What 10 less than 50 is how much? 40. So how did I get 40? I actually did 50 minus 10 equals 40, right? So in our case, that's if I said, algebra to represent 10 less than 50 is this, so that if I say B, I just replace the 10 with B. So it should be 50 minus B, because you have 50 and then you're taking away B amount from it, right? You're taking away that much from it, okay? And that's why I chose to do that for you guys. If you guys watch the video and then still don't understand it, please ask me in the office hours, inshallah, okay? So again, 21 you guys have to do on your own, 23, 24, and 25. So let's go to 22 now, okay? So for number 22, okay, it says there are 20 students in the drama club. Next year, 5 students will leave the drama club. Some new students will join. If D is the number of students who will join the drama club, write an expression to represent the whole number of students in the drama club next year. Okay, so we know that we have 20 right now. Okay, and then it says 5 will leave. What does that mean? What does that mean, Abdurrahman? Yes, it means take away. So we're going to take away 5. And then it says, and some new students will join. If D is the number of students who will join the drama, write an expression. So we're not done yet. We have to say how many people join. How many people join? D people join. We don't know that number. D represents a number that we just don't know. So it could be 100 people, 1,000 people. I don't know. So we just do plus D. Now things can be simplified, right? We have alike terms. We have actually 3 terms. Remember, the terms are the numbers that are adding or subtracting with each other, right? So we have 3 terms. So we have alike terms, 20 and 5, because I can actually add or subtract those. 20 minus 5 is 15, and then plus D. I can't combine these together. 15 is like 15 Snickers and 1 Dorito. What does that equal? 15 Snickers and 1 Dorito. You have to leave it the same. So this is the expression that we have. Okay, again, I said you have to do the next 3 on your own, and we are almost done for today. This is a hard one, so I really wanted to make sure that we did this together. Okay, it says combine the alike terms to write an equivalent expression. So the alike terms are the ones with the same variable, the same exact variable. So if we take a look, this one and this one have alike variables. Why do they have alike variables? Because they both say y squared. And when we combine them, we're just adding or subtracting them together. So in our case, we have subtraction. So we're going to subtract it. So we have 4y squared minus 2y squared. When you have variables, I like to replace them with just a generic name. I'm going to call them yams. 4 yams minus 2 yams is 2 yams, right? Whoops. So I'm left with 2 yams. But I don't want to write yams. What am I going to actually write? Huh? See, Ham, tell me. Yes. I'm supposed to write y squared because that is represented by y, yams. That's what I used to. I used yams to represent y squared. Okay. And now the next part, I can also highlight as well, right? 6x and 6x. These are also alike terms because they both have an x variable, right? And they only have one x variable. Okay. So if I combine those together, 6 xylophones. Am I going to add or subtract? I don't look at this minus sign. I look at the one next to the x. So I do 12, right? So 12x. So 6x plus 12x is what, Zuleika? You're not sure? Why don't you use it as xylophones? 6 xylophones plus 12 xylophones is 18 xylophones, right? So let's use this color. So I get plus 18 xylophones. And this cannot be simplified anymore because they're both different, right? Y squared and X are not the same, so you cannot add them together. So that is your final answer. So again, you guys have to do number 16, 21, 23, 24, and 25. All right. Again, if you guys are having troubles, please go speak to me during my office hours. Other than that, it was a joy teaching it to you guys. Today, I taught nonstop until this time, so I'm really tired, and I'm really glad that you guys are really benefiting from this. Hopefully, I'll talk to you guys later. And again, if you guys have questions, feel free to email me or anything like that. Inshallah. Assalamu alaikum, everybody.